Imagine a perfectly square garden that covers 225 square meters. How long is each side? If we know the side, finding the area is easy, just multiply the side by itself. But here we're asked to go backwards. Let's just try some whole numbers and see which one multiplied by itself lands exactly on 225. 10 times 10 is 100, that's too small. 20 times 20 is 400, that's too big. So the answer is somewhere between 10 and 20. Let's try 15, right in the middle. 15 times 15 is exactly 225, so each side of the garden is 15 meters. That number we hunted for, 15, is called the square root of 225, because two of them multiplied together rebuild the area. Testing numbers one by one works, but for bigger areas, we want a faster way to guess where to start. Grouping digits in pairs helps organize that guess. Let's see why pairing actually makes sense by looking at a few easy squares first. 10 times 10 is 100, a 3-digit number, and 100 splits into exactly one pair of digits, with a lone one left over. Now 100 times 100 is 10,000, a 5-digit number, and that splits into two pairs with one digit left over. Notice the pattern. Every extra pair of digits in the answer needs two extra digits in the area, because each new digit of the side gets multiplied twice, once for each of the two sides. That's why grouping the area into pairs, from the right, roughly locates how many digits the side number will have, and more importantly, tells us which pair to test against first. Let's use this on our own number, 7,225. Grouped from the right, it splits into 72 and 25. Two groups means we're hunting for a 2-digit side. Since 8 times 8 is 64 and 9 times 9 is 81, the first digit of our side should be around 8 or 9. Testing 85, we get 85 times 85 equals 7,225, an exact match. So a square root is just the number that, multiplied by itself, rebuilds the original area, and we found it by testing nearby whole numbers, using digit pairing only to organize the search, not to guess the final answer outright. Now picture a perfectly cube-shaped storage box that holds exactly 1,000 cubic centimeters. How long is each edge? If we know one edge, the volume comes from multiplying that edge by itself 3 times, once for length, once for width, once for height. Let's test whole numbers again and see which one, multiplied by itself 3 times, gives exactly 1,000. 5 times 5 times 5 is 125, too small. 15 times 15 times 15 is way over 3,000, too big. Let's try 10, right between those two guesses. 10 times 10 times 10 is exactly 1,000, so each edge of the storage box is 10 centimeters. That number 10 is called the cube root of 1,000, because 3 of them multiplied together rebuild the volume. Just like before, for bigger volumes we want a faster way to guess where to start. This time we group digits in 3s instead of 2s, and let's see why. Look at 10 times 10 times 10, that's 1,000, a 4-digit number, and it splits into one group of 3 with one leftover digit. Now 100 times 100 times 100 is 1,000,000, a 7-digit number, and that splits into two groups of 3 with one digit left over. Each extra digit in the edge multiplies the volume by roughly 1,000, because that digit gets used 3 times over, once for length, width, and height. That's why grouping the volume into sets of 3 digits from the right lines up with how many digits the edge number will have, and tells us which group to test against first. Let's use this on 13,824. Grouped from the right in 3s, it splits into 13 and 824. Two groups means we're hunting for a 2-digit edge. Since 2 cubed is 8 and 3 cubed is 27, the first digit of our edge should be around 2. Testing 24, we get 24 times 24 times 24 equals 13,824, an exact match. So both square roots and cube roots ask the same kind of question in reverse. What number multiplied by itself, or by itself twice more, rebuilds the total we started with? We found these numbers by testing convenient guesses, narrowing the range, and using digit grouping only to organize where to search, in pairs for square roots and in threes for cube roots. A square-shaped chessboard has an area of 64 square inches. What is the length of one side of the board? Since the board is a square, its area is just one side multiplied by itself. So we need to find the number which, when multiplied by itself, gives 64. That's the reverse question we're solving. Let's test some convenient whole numbers. 7 times 7 is 49, too small. 8 times 8 is 64, that matches exactly. So each side of the chessboard is 8 inches long. A cube-shaped ice block has a volume of 27 cubic centimeters. What is the length of each edge of the ice block? A cube's volume comes from multiplying its edge length by itself 3 times. So we need the number that, multiplied by itself twice more, gives 27. Let's try 2. 2 times 2 times 2 is 8, too small. Let's try 3. 3 times 3 times 3 is 27, that's exactly what we need. So each edge of the ice block is 3 centimeters long. A square rug covers 121 square feet of floor. Find the length of each side of the rug. Since it's a square, we need the number that multiplied by itself gives 121. Let's narrow it down by testing nearby whole numbers. 10 times 10 is 100, too small. 12 times 12 is 144, too big. So the answer sits between 10 and 12. Let's test 11. 11 times 11 is 121, that's an exact match. So each side of the rug is 11 feet long. A cube-shaped storage tank holds 125 liters of water. What is the length of each edge of the tank? Since it's a cube, the volume is edge length multiplied by itself twice more. We need to find that edge number by testing and narrowing down. 4 times 4 times 4 is 64, too small. 6 times 6 times 6 is 216, too big. So the edge is between 4 and 6. Let's test 5. 5 times 5 times 5 is 125, exactly right. So each edge of the storage tank is 5 meters weight. 5 liters worth of edge is actually 5 centimeters, since the volume was given in liters, which correspond to cubic centimeters here. Each edge is 5 units long as given by the problem. A square courtyard has an area of 400 square meters. How long is each side? We need the number that multiplied by itself gives 400. Instead of guessing randomly, let's notice something about the number of digits to narrow our search fast. If we group the digits of 400 in pairs from the right, we get 4, and 0, 0, that's 2 groups, which tells us the answer will have 2 digits. So we only need to test 2-digit numbers. 20 times 20 is 400, that's an exact match right away. So each side of the courtyard is 20 meters long. A square parking lot has an area of 143,641 square meters. Estimate the range for the side length using digit pairing, then find the exact side length. Testing every number one by one would take forever, so let's use digit pairing to figure out roughly how big the answer should be before we even start guessing. Let's group the digits in pairs starting from the right. 14, 36, 41, that gives us 3 groups, so the answer should have 3 digits. Why does 3-digit groups mean a 3-digit answer? Because 100 times 100 is 10,000, which has 5 digits, while 999 times 999 is just under 1 million, which has 6 digits, so any 3-digit number squared always lands somewhere in that 5 or 6-digit range, matching 3 pairs of digits. So we're hunting for a 3-digit number. 300 times 300 is 90,000 too small. 400 times 400 is 160,000 too big. So it's between 300 and 400. Since the target ends in 1, and 1 times 1 ends in 1, and 9 times 9 also ends in 1, our answer likely ends in 1 or 9. Let's test 379. 379 times 379 works out to 143,641, an exact match. So each side of the parking lot is 379 meters long. A cube-shaped water tank holds 39,304 cubic feet of water. Estimate how many digits the edge length has using triple grouping, then find the exact edge length. Since this is a cube, we need the number that multiplied by itself twice more gives this volume. Let's use grouping in threes to quickly figure out how many digits the answer has before testing numbers. Grouping the digits in threes from the right, 39 and 304, that's two groups, so we expect the answer to have 2 digits. Why does 2 groups mean a 2-digit answer? Because 10 times 10 times 10 is 1,000, which has 4 digits, while 99 times 99 times 99 is just under 1 million, which has 6 digits, so 2-digit numbers cubed always land in that 4 to 6-digit stretch, matching 2 groups of 3. So we're hunting for a 2-digit number. 30 times 30 times 30 is 27,000 too small. 40 times 40 times 40 is 64,000 too big, so the answer is between 30 and 40. The target ends in 4. Let's check which digit cubed ends in 4. 4 times 4 is 16, and 16 times 4 is 64 that ends in 4. So our answer likely ends in 4. Let's test 34. 34 times 34 times 34 gives 39,304, an exact match. So each edge of the water tank is 34 feet long. A square photo frame has an area of 196 square centimeters. Find the length of each side. We need the number that multiplied by itself gives 196. Let's narrow the search using nearby round numbers first. 10 times 10 is 100 too small. 20 times 20 is 400 too big. So the answer is between 10 and 20, and since 196 is close to 200, let's try something close to 14. Let's test 14. 14 times 14 is 196, an exact match. So each side of the photo frame is 14 centimeters long. A cube-shaped gift box has a volume of 512 cubic inches. Find the length of each edge. We need the number that multiplied by itself twice more gives 512. Let's test round numbers and narrow the gap. 7 times 7 times 7 is 343, too small. 9 times 9 times 9 is 729, too big. So it's between 7 and 9, meaning it's likely 8. Let's test 8. 8 times 8 times 8 is 512, an exact match. So each edge of the gift box is 8 inches long. A square field has an area of 2,025 square meters. Find the length of each side. Let's first use digit pairing to see roughly how many digits the answer should have, then narrow it down with testing. Grouping the digits in pairs from the right, 20 and 25, that's 2 groups, so the answer should have 2 digits. So we test 2-digit numbers. 40 times 40 is 1,600, too small. 50 times 50 is 2,500, too big, so it's between 40 and 50. The target ends in 5, and only numbers ending in 5 give a square ending in 5. Let's test 45. 45 times 45 is 2,025, an exact match. So each side of the field is 45 meters long. A cube-shaped storage crate has a volume of 21,952 cubic centimeters. Find the edge length, and then find the total surface area of all 6 faces of the crate. First, we need to find the edge length by finding the number that multiplied by itself twice more gives 21,952. Then, once we know the edge, we can work out the surface area from it. Let's group the digits in threes from the right. 21 and 952, that's two groups, so we expect a two-digit edge length. Why does two groups mean a two-digit answer? Because 10 times 10 times 10 is 1,000, a four-digit number, while 99 times 99 times 99 is just under 1 million. A six-digit number, so two-digit numbers cubed always fall in that 4 to 6-digit range, matching two groups of three digits. So we test two-digit numbers. 20 times 20 times 20 is 8,000 too small. 30 times 30 times 30 is 27,000 too big. So the edge is between 20 and 30. The target ends in 2. Let's check. 1 times 1 times 1 is 1, which ends in 1, so numbers ending in 1 give cubes ending in 1 not what we want. Let's test 28. 28 times 28 times 28 gives 21,952, an exact match. So the edge of the crate is 28 centimeters. Now, a cube has 6 equal square faces, so to get the total surface area, we first find the area of one face, then multiply by 6. One face has an area of 28 times 28, which is 784 square centimeters. Now multiply that by 6 faces. 784 times 6 equals 4,704 square centimeters.